All right, welcome to Unit 6, Lines and Triangles. And this is Day 5, Triangle Congruence by angle, side, angle, angle, side, and hypotenuse leg. So I'm just going to write these ways that you can show triangles are congruent. The three new ways that we've got today is angle, side, angle is one of them. That's a postulate. And you can abbreviate that as ASA, as you've probably come to imagine after the previous day's lesson. What that looks like is that two pairs of angles are congruent and the side between those two angles is also congruent. So maybe a situation, let's see here, like that, where the side has to be between the two angles. That's where you'll use angle, side, angle postulate. You also have angle, angle, side theorem. Oh, this is a theorem. This is where it changes. This one is something that can be proven by way of third angles theorem. And we're not going to get into the proof on this lesson, but because it is a theorem, it can be proven. And what that looks like is you have two angles that are congruent on two pairs of triangles, and the side does not need to be between the two angles on this particular one. So this is angle, angle, side theorem. Again, you can abbreviate that AAS. And the last one then in today's lesson will be the hypotenuse leg theorem. You'll rarely see this one pop up. Don't assume, and you see hypotenuse leg, that's having to do with a right triangle. So the hypotenuse is congruent and one of the legs is congruent. Don't think that when you see a right triangle, it's by default HL. You really need to work through it and see what's going on here. Maybe the right angles are just congruent. But some people see this and think that it's angle, side, side, but it's not. Angle, side, side only works for one specific case, and that's when it's a right angle. So we call it hypotenuse leg theorem. This creates our list of 5 ways to show that triangles are congruent. You have side, side, side postulate, side, angle, side postulate from yesterday. Now we have the angle, side, angle postulate, the angle, angle, side theorem, and the hypotenuse leg theorem. Those 5 ways is the ways that we're going to show triangles are congruent on all of our proofs. In fact, whenever I get a quiz or a test, I actually take a moment to go ahead and write those 5 ways down on my test. It's just side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Making sure that the notation is correct, that I'm not swapping things around and everything. All right, here's example 1. We've been given a little bit of information that angle F is congruent to angle J, and that's been shown over here. And that segment FH is parallel to segment GJ. That's what these little slashes mean, that they're parallel. And I've shown that with a pair of arrows here. Whenever I see parallel lines, I'm automatically thinking things like maybe alternate interior angles, maybe corresponding angles, something along that lines. And that's actually going to get used in our proof on this problem. Now, what we're trying to prove is that segment FH is congruent to segment GJ. Now, that's actually not the case right now. They're parallel, but parallel lines don't have to be congruent. You can actually see a trapezoid if you're needing proof of that. But let's go ahead and show that these are congruent. The way I'm going to do that is I've shown this diagonal, and that's going to be essential for this proof. What I'm going to do is use that with the given to show the two triangles are congruent. Now, if you're a little lost, just state things that maybe you know. For instance, these two triangles are slammed up against each other on segment GH. So maybe we can go ahead and say that it's congruent to itself by reflexive property. That's usually a pretty good bet, as a matter of fact, that if you see a common side or a common angle, go ahead and say that it's congruent to itself. And here we go. Segment GH is congruent to segment GH, and that's by reflexive property. Now, that I've shown that, I'm going to put a little tick mark to show that I showed it congruent. Now, if I'm looking at my list of ways to show that triangles are congruent, side, 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 angle, side, I'm already thinking that this first one is not going to be it because I've already got a pair of angles congruent that was in the given. So it's probably not going to be side, side, side. Maybe side, maybe angle, side, angle even, maybe angle, angle, side. Hypotenuse leg, nowhere was I told anything about a right angle, so I'm just going to kind of cross that one off my list as well. It's not going to be that one. I'm focusing on these three ways right here. Now I'm needing more information because I have one pair of angles congruent, one pair of segments congruent. I need something else. I either need another segment or another angle. So as we're looking at this, there is another pair of angles, and I told you I had to do it with the parallel lines. That if FH is parallel to GJ, this GH is a transversal. And you have specifically the alternate interior angles, FHG and HGJ, congruent to one another. Those are alternate interior angles, and that's actually what's going to set this proof off. I should actually use 2 tick marks on those, since I'd already used 1 tick mark previously for the given. So I'm going to go ahead and say that angle FHG, I can't call it just angle H because there's more than one angle at H, is congruent to angle JGH or HGJ, and that was again by alternate interior angles theorem. And I'm going to abbreviate all this down a little bit. Alternate interior angles theorem. Now, I've got another pair of angles. I do have enough information to use one of these ways to show triangles are congruent. I have 2 pairs of angles and 1 pair of sides, so I know it's going to come down to angle side angle or angle angle side. I'm going to go ahead and scratch off side angle side. That's gone. So focusing on these 2 ways, I'm actually going to be using, in this case, angle angle side. And the reason for that is because the side that's congruent, when I focus on the triangle, is not between the 2 angles that were congruent. So I can't use angle side angle. I'm using angle angle side theorem to show these triangles are congruent. Now let's name these triangles. If I name the first one, the one on the left, triangle FHG, perhaps, then the second one on the right, let's see what corresponds to F. Well, I know angle J corresponds to it, so I'm going to start with J. Then on this one, I went to H, which had 2 tick marks. So if I'm over here at J, I need to go to G with 2 tick marks. And then I'll wrap up at H to name them correctly. Once I've done that, taking a look at what we were trying to prove, segment FH, congruent to segment GJ. Segment FH is the first 2 letters. Segment GJ is the first 2 letters. They correspond, and they are on congruent triangles. So for statement number 5, I'm actually going to go ahead and wrap up with my proof that segment FH is congruent to segment GJ, since corresponding parts of congruent triangles are congruent. And that wraps up this proof beautifully well, and there's nothing else I have to do here. I've shown everything that I needed to. One little tip of advice is that when you are using something like angle angle side, you should be able to look back up through your proof, and in this case, see 2 pairs of angles that were congruent. And sure enough, I see one here on statement 3 and up here in the given. Also, I should see 1 pair of sides that were congruent, and I see that on statement 2. So I was justified in saying this probably. This one's kind of tricky though, since there's 2 of them that deal with 2 angles and a side. So that one is kind of difficult. Alright, and here we're just going to show the 2 triangles are congruent. Most likely, we're not going to need to use CPTCT, or CPCTC on this one. Excuse me for misstating that. We're not going to need to use that here. We're actually just showing the triangles are congruent. So let's start by taking a look here. We'll go ahead and jot down some things from my given. It said that angle PSQ is congruent to angle RSQ. So I'm going to go ahead and include that on my diagram. That's the only thing it really gave me. So I have 1 pair of angles. So as I'm looking at my ways to prove that triangles are congruent, at the beginning of learning this, I really like the idea of just writing out this list every single time and scratching things out as you go. As I'm looking at this list, I can go ahead and scratch out side, 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 since I already dealt with angles. Also, I'm going to go ahead and scratch out hypotenuse leg, since I don't see anything about right triangle. I do see bisector, but it doesn't say anything about anything being perpendicular. So I've got rid of those 2. It's down to these middle 3. And let's see what we can use here. There was another piece of information in the given, and it was that segment QS bisects angle PQR. So when I look at angle PQR, it's getting bisected. So it's getting split into two congruent angles. So angle PQS is congruent to angle RQS. And I'm going to make that my statement too. Angle PQS is congruent to angle RQS, since angle PQR got bisected. This is the definition of an angle bisector. Had to use that in the last unit. Hopefully you recall it. All right. Now, I've all of a sudden got two angles in play on this thing, so I'm actually going to go ahead and scratch side, side, side postulate. It's either going to be angle, side, angle, or angle, angle, side, yet again on this one. Let's see what we've got going on here. I don't see a side anywhere in the given information, but as I look at the diagram, sure enough, there's a segment that's in common between the two triangles again, and that's segment QS in this case. So I'm going to go ahead and state that it's congruent to itself. And that's by the reflexive property. All right, now that I've shown that, let's take a look at what that does for me. When I look at my two angles on a given triangle, the side is between those two angles. It's contained within them. Since the side is between the two angles, that's what cues me off that I need to use angle, side, angle postulate to actually finish this proof. So angle, side, angle tells me that, and look at what we're trying to prove. Triangle PQS, I would use the names that they gave you here in the proof, is congruent to triangle RQS. And that's by angle, side, angle postulate. Notice here, I didn't use corresponding parts of congruent triangles are congruent. I was actually only trying to show the triangles themselves were congruent. And I've done that with angle, side, angle. So I'm done with this proof. I think I got a little crossed up here on my numbering. Let me, oh wow, yeah I did. Let me go back and fix that really quick. That this was justification number 2. This was justification number 3 for reflexive property. Sorry about that. And this was justification number 4. So apologize for the getting off on the numbering there a little bit, but hopefully the concept was sound. That wraps up this day. If you'll let me know what questions you've got on this, I'd be glad to help you out. Thanks. Also, don't forget that your proof partner quiz is coming up. We're going to practice with these proofs a bit next school day, and then you'll actually get to do the proof partner quiz the day after that.